And here is the answer. So you know the revenues and you know the accounting cost. And we, in addition, need to take into account the opportunity cost. And just like in the example, the renting out of the buildings and, well, not being able to do that because I use the building myself, that's an opportunity cost. But something funny happens here. Adrian's salary is posted on the account as €50,000, but you can see that the best alternative use that can be made of Adrian's services is only 40,000 a year. So this is really not the market price of Adrian. The market price is €10,000 lower. So not that much is lost by employing Adrian in the bakery. At least less is lost in terms of money and opportunity cost than just the accounting cost would suggest. So that brings us to the answer. The accounting profit is 600, and then we subtract the three items that are listed here. So the accounting profit is €480,000, and the economic profit is identical to 600,000 minus 50, 20, and 50. Those are the terms that we saw before. But we also need to subtract the opportunity cost of 20,000 because we cannot rent out the building if using it ourselves. And we need to take into account that the opportunity cost of employing Adrian in the bakery instead of elsewhere is not 50,000 but only 40,000. So we have a plus 10 over here. So the economic profit is identical to €470,000. And that completes the quiz question. Then we get to the subject of sunk cost. And sunk costs are costs that should not matter and do not matter for decision making. So the total cost, the TC of a firm, consists of the variable cost and the fixed cost. So total cost is simply the sum of the variable cost and the fixed cost. And the fixed cost are the cost of the firm's fixed input, and they don't depend on how much a firm produces. So it's things like a building, the operating permits and the durable equipment of a firm. So they are just there, and no matter whether the firm produces 10 units, 100 units, or 1,000 units, it can do so in the same building. But even for producing one unit, the entire building is needed. The fixed cost may be partially avoidable, that some money can be recovered in case you decide not to produce, not to be active on the market. Some other costs cannot be recouped because, well, there's no alternative use, say, for the building. So if you don't use it to produce, the only alternative is to leave it empty and nothing happens. So the sunk cost, a sunk cost is part of the fixed cost, but it's the part of the fixed cost that cannot be recovered once it is spent. So examples may be licensing fees, which you cannot sell to another person. The long-term lease contract, it's just gone. And also very specific capital, like if you start, say, a restaurant and you have special uniforms with the logo and the colors of your restaurant. Once you've invested in them, and you shut down the restaurant, you cannot recover the cost of these nice durable uniforms because another restaurant cannot use it because it has your logo and your colors onto it. So it's really a sunk cost. And also the menus that you make or the signs that you make. So the big neon lights on the outdoor, it's just a sunk cost. In 2020, when the pandemic struck, a lot of organizations were confronted with this type of sunk cost. So, for example, if you organize the Olympics in Tokyo in 2020, it turned out that the Olympics didn't go through. So all the t-shirts and merchandise that was already made, it's a sunk cost. There's no alternative use for that. But there is one solution that the organizers came up with. So we tried to postpone the Olympics with 1 year. We organize this in 2021, but we do as if it's still the Tokyo 2020 Olympics. So we don't change the logo such that we can use the original merchandise. So the sunk cost cannot be recouped. So independent on whether you produce and are active in the market or not, the sunk costs do not change. So it should not influence your decision whether to produce or not. And I have a video, and this is a video with Nobel Prize winner Richard Taylor, who interviews some people who go to the stadium. Well, I don't know whether he actually explains the idea of sunk cost, but it's clear that the visitors of the stadium, they don't take into account that the ticket they bought is already a sunk cost. So you can watch that video, and I also made a short overview in the firm context. So a firm needs to decide first whether, so suppose it's already active in the market, it needs to decide whether it remains active in the market by not shutting down or to shut down. So that's the first decision to make at the start of the period. And when a firm shuts down, then it still has to make some cost. And these costs are the sunk cost, so the non-avoidable part of the fixed cost. Now suppose that the firm decides, I remain in the market. So you have a pub, the pandemic struck, but you decided, I'm not going to shut down my pub. I just remain here, and such that I can relaunch once the pandemic is over. Now, once you've decided to remain active in the market, even though you produce zero, you still need to pay some cost. And now you don't only have to pay the sunk cost, but you also have to pay the part of the fixed cost that would be avoidable, but now needs to be paid because you decided not to avoid them by not shutting down. So if you don't shut down, even if you produce zero, you have to pay the entire fixed cost, the avoidable part and the non-avoidable part. Now and then, if you start to produce positive quantities, so you really, as a restaurant, start serving meals, then you have an additional cost, which are the variable costs. And the variable costs are dependent on the quantity that you produce. So you can imagine that if you have a restaurant, if you serve 10 meals, then you need one waiter to serve these meals. But if you serve 100 meals in the evening, then you maybe need 2 waiters, and you also need more input. You need more food and maybe also a second cook. So those are the variable costs of production. Now in the book, in section 7.2, the distinction between the avoidable and the non-avoidable part of the fixed cost is made explicitly. But once you move over to chapter 8, it turns out that all fixed costs are treated as sunk cost. So as from chapter 8, the idea is more or less that if you decide not to shut down, but to produce zero, then you have to pay the entire fixed cost. But also if you shut down, then you still need to pay the fixed cost. So the book is a little bit blurry here and has a slightly more sloppy in chapter 8 than in chapter 7. But you will be able to deal with this given this overview. Okay, then the different costs. The fixed costs are the costs that don't depend on output, and the variable costs are the costs that do depend on output, and the total cost is the sum of the two. And whether the costs are fixed or variable, that's not crystal clear because it depends on the time horizon. So In the short run, there's not much that you can change. So a lot of costs are fixed, but in the longer run, you may be able to sell part of your assets, and some of the fixed costs are no longer fixed, they become variable as well. So let's look at a firm that produces shoes and look at the fixed, variable, and total cost. And this is the graphical exposition. We will get to formulas next. And the cost is on the y-axis in dollars per week. So, and then the variable cost may have the following shape. So it may have many different shapes, but this would be one. So the variable cost is increasing in the quantities of shoes that you produce. You would expect that this function would be increasing and not decreasing. But you can see that the variable cost do not increase a lot for the first 8 or 9 pair of shoes, and then they do increase quite a bit more. And it may be because, given the capital that you have in place in your firm, you are well able to produce 8 pair of shoes in a week. But once you start to producing more, then you need to pay your employees overtime, which is more costly and increases the variable cost of production. Then the fixed cost. By definition, they don't depend on the quantity that you produce. So even if you produce 0, then you need to pay the fixed cost of 50. But the good thing is that once you produce more pairs of shoes, your fixed costs don't increase. They remain the same. Now the total cost is the sum of the two. So you vertically aggregate the two lines and you get to the total cost function. So here, if you don't produce, the total cost is equal to the fixed cost because there's no variable cost involved. And then if you continue, the more you produce, the more your total cost will be determined by your variable cost. So back to the bakery. So suppose I need ovens and I need them anyhow, no matter how much I produce. So that's clearly a fixed cost. And the amount of flour that I need will depend on how many loaves of bread I produce. So the amount of flour and the cost of flour is certainly a variable cost. Then two more concepts. So the average and the marginal cost. The average cost is simply the total cost divided by the number of units that you produce. So in formula, we can distinguish between the average fixed cost, which is the fixed cost divided by the quantity produced. So AFC, nothing to do with a certain football club. It's just the average fixed cost is the fixed cost divided by quantity Q. And the average variable cost is the variable cost divided by Q. Then the average total cost is the total cost divided by Q. So it's the average fixed cost plus the average variable cost. Now the marginal cost is also a very important concept because you don't only need to decide on whether to shut down or not, but given that you are active in the market, that you don't shut down, you need to decide how many units to produce. So, and for any unit that you produce, you can ask the question, okay, by how much will my cost increase if I produce another unit? What is the incremental cost of producing an additional unit? Now, that is what we call the marginal cost of production. So it's the change in the total cost if you increase the quantity that you produce by 1 unit. And then in the limit, we take very small changes, so we don't increase the production by 1 unit, but it says, okay, what is the derivative of the total cost function with respect to the quantity produced? So then we get the slope of the total cost function. That was in formula, graphically, so average cost curves. So the average cost of producing shoes is the average variable cost is first decreasing and then increasing. And we observe that our variable cost was very modestly increasing for the first 8 pairs of shoes, but then we saw this slope upwards, which means that the variable cost, you could distribute them over more and more pairs of shoes until 8 pairs. So the average variable cost, they went down, but they start increasing again if you produce more than 8 pairs of shoes. Now the average fixed cost, the fixed cost is set at 50, which means that if you produce 1 pair of shoes, then the average fixed cost is 50, 50 divided by 1. If you produce 2 pairs of shoes, then the fixed cost of 50 is divided over 2 pairs of shoes, so the average fixed cost is equal to 25, and so on and so forth. So the average fixed cost always falls as the quantity rises, and the average total cost is the sum of the two. So you vertically aggregate the yellow line and the green line, and you end up at the blue line, which denotes the average total cost. Now then there's a relation between the average and marginal cost, and let's do an example close at home. Suppose that your average grade is 7.0. What happens to your average grade if your next grade is lower than 7, and what happens when it's higher than 7? Now, easy to answer. If your next grade is higher than 7, then your average grade will increase. If your next grade is lower than 7, then it will decrease. So this implies, and it works here the same, that if the marginal cost is higher than the current average cost, then the average cost will increase. If your marginal cost, the incremental cost of producing an additional unit, is lower than your current average cost, then your average cost will decrease. Which implies that the marginal cost function crosses the average cost function at the minimum value. So, and the same holds for the average total cost function and the average variable cost. And I have a picture on the next slide. So the average total cost are minimized when the average total cost is equal to the marginal cost. And the average variable cost are minimized when the average variable cost is intersecting with the marginal cost curve. Now in pictures, to get a feel for this, so we have a quantity again on the x-axis and the average cost and the marginal cost on the y-axis. So the average variable cost is depicted by the yellow line, the average total cost is depicted by the blue line, and now we will add the marginal cost function. And just like with the grades, as long as the marginal cost is lower than the average variable cost, then the average variable cost should decrease. Once the marginal cost is higher than the average variable cost, then the average variable cost should increase, which means that the marginal cost curve needs to intersect with the average variable cost curve at the minimum point. And the same for the average total cost. As long as the marginal cost curve is below the average total cost will decrease. Once it is above the average total cost curve, the average total cost will increase. So it intersects with the average total cost curve at the minimum value. So the marginal cost curve will look something like this. That was the graphical exposition. Now some specific formulas. Suppose that the total cost curve of a firm is given by TC is 10q squared plus 6q plus 60, and the marginal cost is given by 20q plus 6. Of course, you need not to be given the marginal cost function here, because you can derive it from the total cost function, because the marginal cost is the derivative of the total cost with respect to q. And taking the derivative of the first equation gives you 2 times 10 is 20q, plus the derivative of 6q is equal to 6. But Okay, the book makes it easy for you by often giving the marginal cost function, whereas it actually should not be given because you are able to derive it from the total cost function. Now answer the following questions. Find expressions for the firm's fixed cost, variable cost, average total cost, and the average variable cost. That's the first question. Actually, it's 5 questions into one. Find the optimal output level that minimizes the firm's average total cost, and find the output level that minimizes the average variable cost. And of course, the second and third questions really bring back into your memory the figure that was shown on the previous slide. And the idea that the marginal cost function intersects with the average total cost function and the average variable cost function at the minimum point certainly is something that you will use in answering questions 2 and 3. But we start with question 1. So the total cost is the sum of the variable cost and the fixed cost. And the fixed cost is the part of the total cost that doesn't depend on output. Well, we clearly see that the first two terms, 10q squared plus 6q, they have a q, so they depend on how many units you produce. So this cannot be the fixed cost, this should be the variable cost of production. The fixed cost is the part that doesn't depend on output. Well, we have a constant here equal to 60. So this should be the fixed cost of production. Now, alternative way of getting at it is just to plug in the values of 0. What is my cost that remains if I produce an output of 0? So we get 0 squared is equal to 0. And 6 times 0 is 0 as well. So these two terms cancel out and we are left with a total cost of 60, which is then the fixed cost. The cost when we produce 0 output. The variable cost is the portion that does vary with output. So if the 60 is the fixed part, then the remaining part that is a function of Q is the variable cost of production. Now the average total cost is simply the total cost divided by the output. So we divide the total cost function, this expression, by Q, and we arrive at an expression 10 times Q plus 6 plus 60 divided by Q. We can do the same for the variable cost. So the variable cost divided by Q gives us 10Q plus 6. And that completes question 1. Then question 2 is find the minimum average total cost. So the total cost function at the minimum point should be equal to the marginal cost. Both were on the previous slide. So the average total cost is this expression. Our expression for marginal cost is equal to 20q plus 6. So we have one equation with one unknown, q. So we can solve for q, and that will give us the quantity that minimizes the average total cost. So working out all the terms and solving for q, we arrive at q is equal to square root 6, so about 2.2045 units. And we don't round it to integer units. We just write down, we treat the output as a continuous quantity, and we don't care that you can produce 2.45 pairs of shoes. No one will be very happy with the last 0.45 pair, but we just ignore this and we treat production as something that is continuous. Likewise, the average variable cost is minimized where the marginal cost is equal to the average variable cost. So again, equating the average variable cost to the marginal cost. So this is the average variable cost, this is the marginal cost. And we see that the only value of Q for which 10Q plus 6 equals 20Q plus 6 is the value Q is 0. So the average variable cost is minimized at a production level of 0. So meaning that once we start to produce, our average variable cost is increasing. Well, why is that? Because in this example, our marginal cost is increasing. So any incremental unit will be more expensive to produce than the preceding unit. So the average variable cost is minimized when we totally quit producing any units. That doesn't need to hold in general, but it holds for this specific case because here we have an increasing marginal cost function. So we have 20q plus 6. We will also come across examples where the marginal cost is constant, so it doesn't involve this q term. This brings us to the next quiz. And the next quiz asks you, or first it gives you a cost curve. It says, well, suppose that the cost curve is 5 times q squared plus 10q plus 100. And the questions will not come as a surprise to you. Find expressions for the firm's fixed cost, marginal cost, variable cost, average total cost, and average variable cost. Again, this is not one question. It's more like having 5 questions into one. Find the output level that minimizes the average total cost and find the output level that minimizes the average variable cost. Good luck. It should not be a problem if you have paid attention to the figure it out that we just did. And I will see you after the break.